All right, hey guys. So we are moving on to Unit 6, and to start off for Unit 6, we are going to be talking about recognizing different types of functions. And so our objective for this lesson is to identify linear, quadratic, absolute value, and exponential functions, whether they're in graph form, table form, or equation form. So our notes is just this big chart that has the different kinds of functions. These 4 different types of functions we're focusing on: linear, quadratic, absolute value, and exponential. And then these 3 different forms, we can see them in graph, equation, or table. And it's going to help you see how to recognize them in each form. Just a quick note at the bottom. These are 4 of the most common types of functions, but there's lots of other types too. So these are not the only types of functions you'll come across. They're just some really common, important ones that we want you to be familiar with. So the goal here is for you to be able to either look at a graph, an equation, or a table and be able to identify what type of function it is if it's one of these 4 types. So to get started, first we're going to talk about what the graphs look like. Linear equations. You guys have been doing a lot of quadratic equations this year, but if you think back to previous years, do you remember what linear equations look like? So a linear equation is going to be a straight line. So on your graph, go ahead and draw an example of a linear equation. Any kind of straight line. It can be positive slope. You could have one have a negative slope. But just some kind of straight line to help you remember what a linear equation looks like. And it's going to look like a line, a straight line. All right, for a quadratic equation, let's do a quadratic equation next. So quadratic equation, that's what we've been working on. You guys should be familiar with what they look like. It is a parabola. So go ahead and draw an example of a parabola on your notes. All right, yours doesn't snap into place like mine does, but that's okay. Just do your best to draw that U shape. Starts wide and then gets narrow and then wide again. All right, so our quadratic functions are a parabola. Again, remember they can be upside down. If you have a negative in the front of it, they'll be upside down, or they can be right side up again. So either one of those is fine. You can draw whichever one you want. All right, moving on, absolute value. It's probably been a while since you've seen some of these. They are V-shaped, so they're going to look something like this. All right, so again, they can be moved around. They could be, moved around anywhere. Or, again, they could also, let me get my pen back. They could also be upside down. All right. And last but not least, this one might be new to you, exponential functions. So an exponential function, it says they're nearly horizontal on one side, and on the other side they approach vertical. So what that means is on one side they mean kind of one side of our y-axis. So on one side they're almost flat, and then as they get close to the y-axis they start to go up, and then they go up pretty steep. So they look kind of like that. Again, they can be like a mirror image of that. They can be flip-flopped, but that's kind of the basic one, looks like that. So I know that one is a little bit newer to most of you. So try to draw that one as neat as you can so that you'll be able to recognize it. All right, so you should have a picture of each of your types of functions. So you should be able to have an example of what they look like in graph form. Let's move on to what the equations look like. So we're going to be looking at their equations. So for a linear equation, and I'm going to zoom in on linear for a bit. For a linear equation, it says the highest degree of x is 1. And so your most basic linear equation is just the function y equals x. But it also could be something like y equals 2x or 2x plus 1. So those are examples of linear equations. Quadratic equations, you guys have been working with a lot. Again, the most basic quadratic equation is y equals x squared. And we're going to put in some more examples here, so leave some space. I just want to get you some basic examples. Absolute value is going to have absolute value symbols. And so those are those bars like that. So y equals, for example, the absolute value of x. And if you don't remember what absolute value means, it means you take away the positive or negative sign. It's just always positive. It means, so it gives you the distance. All right. For exponential equations, it says the x is part of an exponent. And so when you have an exponent, usually we think of numbers in the exponent, like a square or to the third power. But in this case, the x is going to be up there. So you're going to have something else down below, like 2, for example. That's your base, and then the x goes in the exponent place. So that would be an exponential equation. So I'm going to go ahead and pull up some other equations, and we're going to see if we can figure out where they go. Actually, okay, that works. All right, so we already did y equals x. We did y equals x squared, absolute value, and this exponential one, 2 to the x. Let's look at this one, y equals negative 3x plus 2. What kind of equation would that be? Which kind of function would that be? So if you look at the power of x, there's no exponent on the x, and the x isn't in an exponent, but the highest degree of x is 1. So that is going to be a linear equation. So we can write that one as an example of linear. All right, next one. Hopefully you guys are familiar with this one. It's got a x plus 1 in parentheses squared and then minus 9. So that square on the outside of the parentheses is going to square our x, which means our highest degree of our x is 2. So that means it's going to be a quadratic, and you guys should hopefully recognize that as a quadratic in vertex form. So let's put that in our vertex box, or our quadratic box. All right. Oh, and I was going to show you these after we decided what they were. So that one, yes, is a quadratic. And then that first one, yep, was linear. All right. Next, here's another one. So y equals x divided by 2 minus 3. And the way that one's written might be a little tricky. You could also think of it as 1/2 x minus 3. And then you might recognize it as a linear equation again. So y equals, and I'll write it that way here, 1/2 x minus 3. So we have that slope and then the number at the end. So there it is. There's our linear equation. You can see it graphs into a line. Okay. Next one, this one right here. So y equals negative absolute values of x plus 1 and then plus 5. So the dead giveaway there obviously is the absolute value sign. So go ahead and put that one in your absolute value example box. They're pretty easy to spot because of those absolute value symbols. And then let's see what that looks like in the graph. So it looks very similar to what we drew, an upside down V. And it's upside down because it has the negative in front of it. All right. Moving on, we have x minus 2y equals 6. So again, our x, the highest power on our x is just a 1. The degree of x is 1. So that's going to be another linear equation. It's in a different form that you probably aren't used to using as much, but that is a linear equation as well when you have it in that form. So let's go ahead and put that one in the box too. Hopefully you have enough room for all these. X minus 2y equals 6. So that's actually standard form when you have the x and y on the same side of the equation. Let's see what that one looks like. There, it's a line. All right. Number 10 here, we have y equals 1/2 times 5 to the x power. So that is going to be another example of an exponential equation because the x appears in the exponent. All right, and let's graph that one and see what it looks like. So you can see it's nearly flat or nearly horizontal on one side, and then it gets very steep and goes almost vertical on the other side. All right, number 11, again, I accidentally erased it. Let's undo that. Okay, 11. This one, again, should also look familiar from what we've been working with recently. That is a quadratic in intercept form. So we'll go ahead and put that in our quadratic box. All right, and let's graph it to see what it looks like. Yep, there's our parabola. All right, next one, we have y equals 4 to the power of x minus 1. Again, there is an x in the exponent. There's other things too, but because the x is up there in the exponent, that's going to be exponential. So let's see how it looks, and we'll go ahead and write that down there. And sometimes you might not see it with the parentheses, so I'll write it without the parentheses, like that. When you're putting it in a calculator, sometimes it's easier to put the parentheses on it to make sure you're staying up in the exponent space. All right, so we've gotten some good examples of all 4 of our different types of equations, so hopefully that can help you recognize what they look like in equation form. I'm going to give you one example that, like I said, there's other types of functions besides these 4. Here's one that maybe you haven't seen before. This is what the function y equals sine looks like. So that doesn't look like any of our pictures. Sometimes you'll have functions that don't belong in any of the categories, and that's okay. It's none of the above. All right. So let's go ahead and go back to our notes. The last way to recognize what type of function we have is by looking at a table. And it is the way that takes the most work. It's a little bit harder to figure it out. You can't recognize it right away. You have to do some work to figure it out. So there's a process, and so I'm going to show you how to do it. So first of all, to do the process, you have to make sure that the x's in your table, so you have a table that has x's and y's, right? And you want to make sure that your x's, that they go up incrementally, sequentially, in even steps. So for example, right here, -1 plus 1 is 0, plus 1 is 1, plus 1 is 2, plus 1 is 3. So those are all in order, evenly spaced. If your x's are not evenly spaced like that, then these rules aren't going to work. The tables we're going to give you are going to be nice like that, but I just wanted to, just that disclaimer that it does have to be even like that for this to work. All right, so when your x column is sequential, then what you're going to do is you're going to look at how the y values change. And so what you're going to do is you're going to figure out, usually you're going to be looking at the difference between them. You're going to see what you have to do to get from this y value to this y value. So to go from 5 to 2, I had to subtract 3. And then to go from 2 to -1, I subtracted 3 again. To go from -1 to -4, again, I have to subtract 3 again. And from -4 to -7, I'm subtracting 3. So as you can see, every time I subtracted 3. So those differences are constant. Each step, it says each step adds a constant, or it could also be, or subtracts a constant. Or subtracts. You can add that if you'd like. So each step adds or subtracts a constant, but those differences, so this group right here, this row of differences are all going to be the same. -3, -3, -3, -3. That's how you know it's linear. So when you figure out what those differences are, and if it's all the same, then you have a linear equation. So let's go on to quadratic, and we'll see how it's different. So in quadratic, let's go ahead and find our differences. So again, just double check. Yes, our x's go sequentially, so we're okay on there. All right. So to go from +1 to 0, I had to subtract 1. Then to go from 0 to 1, I had to add 1. From 1 to 4, I had to add 3. And from 4 to 9, I had to add 5. So those are not the same. Obviously, I'm doing something different. I'm not adding or subtracting the same thing every time. So my first differences are not constant. But it says for quadratic, my second differences are constant. So what I'm actually going to do is I'm going to do the same thing again. Let me do it in a different color here. So now I'm going to find my differences again. So to get from -1 to +1, I had to add 2. And then to get from +1 to +3, I had to add 2. And from +3 to +5, I had to add 2. So now you see that when we've gotten our second differences, those are constant. So our first differences were not constant. That's in the red. Our first differences were not constant, but our second differences were. So that gives us a quadratic. So linear, first differences are constant. Linear, the first differences are constant. Quadratic, the second differences are constant. So both of these things, though, you're going to be looking at what those differences are. All right, moving on to absolute value. We're going to do the same process. We're going to look at those differences. So again, I'm just going to make sure that these are going up evenly. This time they're going up by 2, but again, they're going up evenly. I'm adding 2 each time, so that's fine as long as they're going up sequentially. All right, so let's find my differences. All right, so from 4 to 3, I have to subtract 1. From 3 to 2, I have to subtract 1. From 2 to 3, I'm adding 1. And from 3 to 4, I'm adding 1. All right, so what it says for absolute value is it says that our first differences are going to be constant, but then they're going to switch to the opposite constant. So if you look at them, the number is the same the whole way through. They're all 1, but it switches from -1 to +1 at some point. And so that's what's going to happen with our absolute value. It's going to be constant one way, and then it's going to all of a sudden switch and be the same constant going the other direction. So that's how you know it's absolute value. So you're going to have the same constant both times, or the same number, but it's going to switch from positive and then it's going to go to negative, or it's going to start off negative and then it's going to go to positive. But the number will stay the same. All right. So that's absolute value. So as you can see, for all 3 of these so far, the first thing we've done is we've found what those differences are. So that's always your first step when you're looking at the table. All right, last one for exponential. So for exponential, let's go ahead and look at our differences. All right, we have a fraction here, but that's okay. From 1/4 to 1, I added 3/4. From 1 to 4, I added 3. From 4 to 16, I added 12. And from 16 to 64, get out the calculator, I added 48. And I should be putting a plus there because I'm adding them. All right, so this is definitely not linear because I'm not adding the same thing. So let's go ahead and check and see if it is quadratic. Well, it's also definitely not absolute value because it's not the same number. So we've ruled out absolute value. We've ruled out linear. Let's check quadratic. So from 3/4 to 3, I have to go up 2 1/4. And then from 3 to 12, I got to go up 9. I can already tell this isn't going to be quadratic because these are not the same. 12 to 48, I'm going up 36. So it's not quadratic either. So this isn't getting me anywhere. Let's try a new approach. So with exponential, it's not going to be about adding a constant. It's going to be about multiplying a constant. So right here, each step is going to multiply a constant. And so if you've tried adding and the adding stuff isn't working, then try multiplying. So I'm going to erase this right here so we have some space. And we're going to try multiplying. So what could I multiply? Let's do that in orange. What could I multiply times 1/4 to get to 1? I could multiply by 4. 4 times 1/4 is 1. And then 1 times 4 is also 4. 4 times 4 is 16. And 16 times 4 is 64. So each time I'm multiplying by 4. So that works out. Each step multiplies by a constant. Sometimes these can be harder to think about. Another way you can do it is you can think of them as the ratio between steps. So I like to sometimes divide. I'll look at this number, and I'll go 64. I'll go 64 divided by 16 equals, and that will equal 4. And then I'll try these two numbers. 16 divided by 4 equals 4. and then go up again. 4 divided by 1 equals 4. So it's that constant ratio between the steps. Your ratio is always the same. A clue to maybe try checking if it's exponential before you try adding, try seeing if it's one of the other types, is look at how quickly the numbers get big. As you can see, the numbers got really small and they went from really small to really big really fast. They went from 1/4 to 64 quite quickly. Exponential does that. If you look at the graph, it starts off really flat and then all of a sudden it zooms up. And so the numbers are going to get big quite quickly usually. So if you notice that that's what's happening with your table, you might want to check to see if it's if your steps are being multiplied by a constant instead of being added by a constant. All right, so there you have it. You have your chart. You have an example of what a graph looks like, what equations look like, and you have the rules for how to check what type of equation it is based on a table. Again, remember there are other types of equations besides these 4. So if it doesn't fit into any of these rules, then just it's not one of these. It's a different type of function and that's okay. So good luck and I'll see you later. Bye.